a problem where we find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. So we have a solid of rotation, and we're going to find the volume of that solid of rotation. Part of this is sketching the graph. I think that this graph is hopefully sort of a quick one, a little quick graph where, let me do the easy one. I have y equals x cubed, y equals x. I think they're sort of both easy. Keep in mind the directions that tell us that x is greater than or equal to 0. So that's going to, sort of restrict where we're looking when we sketch the graph. So y equals x is sort of the first one that I can do sort of easily. And then y equals x cubed, when x is greater than 0, it looks like an upward facing parabola. Not really much difference in the way it looks unless I carefully plot points. It turns out in this section of the book, a whole bunch of these problems have the point of intersection is just the point 1, 1. Let's find the point of intersection by using algebra, but really just by carefully sketching the graph, if you know the graph y equals x cubed, you know that point is 1, 1, simply because 1 cubed is 1. All right, but you could set these two equal to each other and solve that way. So you get x minus 1, x plus 1. We're only going to look at the point of intersection, or at least that part of the graph where, where x is positive. Okay, so I'm glad that went a little faster than some of these other graphs because we still have quite a bit more to do. We're going to rotate about the x-axis. So maybe it's cheating, but I can just copy and paste this picture, and then I'll just do that rotation. You just try your best on the rotation part. So say it comes down like this, rotate a bit. I feel like that wasn't so good, but I start getting maybe too much, too careful and put too much pride into it, trying to make it too good, but I can do better though. Okay, the thing is, there's an inside part that's being scooped out. So this is like sort of like a bowl or something like that. And see now what happens is if I cut this, if I take a cut of this, what does that cut look like? That slice. What does the slice look like? The slice is, the slice has a hole in it. It's a washer. Okay, getting too carried away with this program again. Anyway, it has a hole in it. So let me just go back and color this all this. So it's a washer. So it has a hole. This whole thing has a hole in it, and that makes it a washer. All right, so that's sort of dumb to do that, to spend so much time on it. The thickness is dx. Okay, now I'm going to use a volume formula, and we'll rotate around this line, and the line is coming through the middle, which is the line y equals 0, which is the x-axis. So I have a whole formula set up, integral from a to b for the volume of rotation, where I take pi r squared. All right, what I'm doing here, let me just back up just a little before I write down that big formula. The volume is the integral from a to b of the area of the face of the slice times the thickness of the slice, which is dx. So what is the area of the slice? Well, the slice, as you see, which is a washer, this guy, when I slice this, I look and I see a circle, and the area of the circle is pi r squared. But then there's a hole, and that hole has area pi r squared. So that's our area function. But what is the area, or what is R? So R is going to be defined by this function that's on the outside, which is y equals x. So this is pi r squared, and r is equal to x. It's because of this, the way this is working is that the outside is y equals x. But then there's a little, okay, I don't know where I can show that because the whole thing is very messy once I start showing more of this. But this distance from the top to the bottom is going to be that the length of that vertical line segment that I just wrote there, that I just drew there. That length of that vertical line segment is r, and that, how do you find the length of that? You take the y value at the top, which is x, and the y value at the bottom, which is 0, and so you get x. Now, on the one on the bottom, I have the function on the bottom, I have x cubed. By the same reasoning, if I draw a little line segment, I've already used up sort of the good color here, but if I draw a line segment, that little line segment is going from y equals x cubed down to y equals 0. Now, before in class, I put this all together in a big formula. So let me write down the formula, because I sort of just jumped ahead, and let me write down the formula that I want to write. The grandmother of all formulas is pi f of x minus L squared, where this is the outer, minus pi g of x minus L squared, and this is the inner function, and where this is about the line y equals L. But in this case, L is equal to 0 because it's the x-axis. And also, since I started putting in numbers, I'm going to put in A and B. A and B goes from 0 to 1. It's x equals 0 to x equals 1. So anyway, so this actually becomes sort of a fairly easy problem. I mean, really, in terms of integrating. What do you do with x to the third raised to the second power? You multiply 3 by 2. Not add, not 3 to the second power. Anyway, you multiply 3 and 2. So this is going to give pi, and this is sort of shaping up to be easy, but let's see if I can take victory and throw it away. I was reading about the Jets playing. They almost won the game just recently. The Jets almost won the game, and then they just made like the worst call in history and threw away. Let's see if I'm going to throw away my victory and lose the game by just adding fractions wrong. So maybe someone will point out. See, it's making it such an important play that it's made it into a math class. It's made into this Jets Raiders. That's right. It's Jets Raiders. Apparently they made a blunder. Okay, anyway, 4/21 pi. How about we look at it first carefully before I even look up the answer in the back of the book, or not? Just look at the answer in the back of the book. This is 6.2, number 7. Yes, that is correct. That is the answer in the back of the book. How about questions about this? Anybody want to, shall we chat about this a little bit? See, what I did is I ran through the finish line. I didn't make a mistake at the very end like I often do. I kept going all the way through. All right, it's a lot. You're supposed to sketch the graph. I have this big granddaddy formula, whatever you want to call it, the formula that's going to solve all of the rotations around a horizontal line. You have to know how to use the formula though. But it's by the way, if you get a negative answer, it's possible that you've reversed. So it's a volume, so it can't be negative. But it's possible you reverse the order of subtraction there. So you want to get the one outer. What I mean is the function farthest away from the rotation, which is x, and x cubed is closer to the rotation.